So in our next section, we're going to talk about some of the details of what do the different DMVPN phases mean. So specifically, what is the difference between phase 1, phase 2, and phase 3? And then what is the ultimate effect of this when we're looking at it from a routing protocol point of view and from a routing design point of view? Now, when we're talking about the three phases of deployment, they're aptly named phase 1, 2, and 3. What this is ultimately going to affect is what are the spoke-to-spoke traffic patterns, what are the supported routing designs in terms of can we do summarization or not, and then how big can we get the network to scale. Now, the first variation that we looked at up to this point is considered DMVPN phase 1. You could still configure this if you want to, but technically it's obsolete. There's no really advantage of doing this. What DMVPN phase 1 means specifically is that we have, what it means specifically is that we have a multi-point GRE tunnel on the hub, but we have point-to-point GRE tunnels on the spokes. So as we saw on the spokes, we configure the tunnel destination manually, which means that when they actually go to encapsulate the GRE packet, they already know what the destination is. The destination is going to be that static address that we configured as the tunnel destination. Now, in the case of the hub doesn't have the destination configured. The tunnel mode is configured as GRE multipoint. So this means that the spokes need to register with the hub in order to tell the hub what are the particular NBMA to overlay address mapping, or what is the public to private address mapping. And the end result of this is that we're not allowed to have spoke-to-spoke tunnels. Because when we go to send the packet out the GRE tunnel on the spoke, they already know what the destination is. They cannot query the NHRP database in order to figure that out. Now, in phase 1, the routing domain or the routing design is simple. You're allowed to do summarization from the hub to the spokes. You're allowed to do default routing. And we'll see that the next hop value on the spokes is always changed to what the hub is. So if we're doing RIP and we send an update from one of the spokes up to the hub, and then the hub sends it back down, the hub is going to set its own address to be whatever the next hop is. Now, we'll see that when we're running OSPF over DMVPN, there are some other limitations as to what are the network types that we can run, this is where it's going to come into play with the phases. Which type of OSPF configurations are you allowed to specifically do? So we'll take a look at that in later sections, but with phase 1, this is the simplest of the designs because you're just using a point-to-point GRE tunnel on the spokes. The only thing that's different is that we're using NHRP on the hub in order to get the spokes to dynamically register. Now in phase 2, which is technically considered obsolete as well, we're running multi-point GRE on both the hub and the spokes. So this means that NHRP is going to be required for the spokes to register to the hub, but it's also going to be required for them to query each other's addresses if we wanted to do direct spoke-to-spoke tunnels. So again, the idea of the DMVPN is that if the spokes want to send traffic directly to each other, we don't want to have to physically route the packet to the hub decapsulate it, the hub re-encapsulate it, and then send it back down to the other spoke. Because it's not only inefficient in the data plane, it's going to be inefficient in the control plane as well to do that. Now, from a routing point of view, we're going to see in phase 2 there's much more restrictions, or there's many more restrictions as to what the routing design is. So summarization and default routing is not allowed when we are running in phase 2. And the reason why is that the next hop value has to be preserved by the hub, and the spokes need to have specific routes to each other's networks in order to trigger the point-to-point or the spoke-to-spoke tunnels. So when you go to add multiple levels of hierarchy of this, it means that the hubs basically need to be joined to each other's clouds, that is a case where the hub is both a next hop server and it is a next hop client of somebody else. Now, the current recommended design, or what we call DMVPN phase 3, is still where we're running multi-point GRE on the hub and the spokes. We still need NHRP in order for the spokes to register with the hub, and then NHRP is going to be needed for the spokes to figure out each other's addresses. Now, the difference here is that when the hub receives an NHRP request, and it gets sent back out the same interface, the hub is going to send an NHRP redirect to the remote spoke, in order to tell them to update the routing table. Now we'll see what this means, and it depends on the particular version that you're using. In the original implementation of this, the change was transparent and you could only see it in the forwarding table or the fib or the ceph table. But in the current versions, the change is made in the rib, and there is a new special route type that is an NHRP route. So basically what happens is that when the traffic goes from the spoke to the hub, and the hub says your destination is reachable via another spoke, I send a redirect back down, which causes them to install routes to each other. Now what this means from a routing point of view is that summarization and default routing is allowed. And this is the big scaling factor of DMVPN Phase 3. That if you're running either eIGRP or BGP, since the hierarchy of the network is arbitrary, you can summarize wherever you want. But the issue is if you were to run OSPF, you could only summarize between the area boundaries. So this means that all of the spokes would have to be in the same failure domain and the same flooding domain. So if there's a change on one of the spokes, it causes all of the other spokes to rerun SPF. Or if there's an update on one of the networks, it's going to cause a flooding event on all of them. And the issue that you run into with that number of spokes, and typically if these are small routers that are maybe connected on DSL or cable, they might not have the most stable circuits. So do you want a flapping link to cause 1,000 other spokes to reconverge the network? Probably not. So we'll see that when we look into the details of choosing a routing protocol over DMVPN, in general, you don't want to use OSPF. You would technically be better off running RIP routing over DMVPN than running OSPF, because it doesn't allow you to summarize from the hub down to the spokes efficiently without having to redesign the entire network in order to fit into that strict hierarchy of leaf spine leaf. Because in the core of OSPF, we have to have area 0, and that's the place that we can summarize from the area 0 ABRs down to the other routers. So without having to do like redistribution and other external domains, it makes this very complicated. But in the case of either eIGRP or BGP, hierarchy is arbitrary. So we can summarize from the hub down to the spokes. We can give them just a default route. And from the spokes back up to the hub, we can summarize as much as possible. In the case of eIGRP, as we previously saw, this is what breaks the query domain. So if I have a reconvergence event and I go to ask you, do you have an alternate route to this destination? If I have summarized the prefix to you, you're going to reply back to me and say, no, I don't have a route to it because you asked me for a /31 and I only have a /24, so I can't help you out. So the idea is to try to hide as much of the visibility as possible in the network, but still allow to have optimal forwarding between the spokes, which is ultimately what Phase 3 does. Now we'll see that the next top value that is used in Phase 3 is going to be pointing towards the hub, which means that the routing design is more flexible. So you could run OSPF point to multipoint over Phase 3, but again, typically we probably would not want to. Now within our scope, within the case of the ccie lab exam, we need to know all the variations. So when we get to the actual configuration of this, we're going to go through each of them step by step and look at specifically what's the difference between Phase 2 and Phase 3. When can you run network type broadcast? When can you run point to multipoint? In eIGRP, when do you need to turn off split horizon? When can you leave it on? When do you need to leave the next hop the same? When you need to change the next hop? And then the same with BGP as well. So all of this really boils down to, do I want to have dynamic spoke-to-spoke tunnels? And if I do I need to have specific routes between them in order to accomplish that goal? Now we'll see the configuration of this is very straightforward beyond what we currently had. It's only one extra command on the hub, which is the NHRP redirect command, and there's one extra command on the spokes, which is the NHRP shortcut. But beyond that, it's more of a routing design issue, not necessarily a configuration problem. It's that once you say, okay, I'm going to run OSPF over DMVPN, you're locked into that. That you're not a month later going to want to come back and say, okay, I'm going to update all 1,000 of these spokes and rechange my routing design. It's going to affect a lot of other things. So from a new deployment, you kind of have to think about this. Does your network fit into a strict hierarchy? And if it does not, you do not want to run OSPF. So for large-scale deployments of this, the best case is going to be to use BGP, because BGP is meant to scale, and you can do whatever routing policy you want. And we'll see that there's some quick fixes, like you can run dynamic BGP peer groups to say that the hub just listens for TCP SYNs from the spokes, and then it automatically forms a BGP peering to them. So you wouldn't even necessarily need to track all of the manual neighbor statements. You just give them a range of addresses, and then you point the spokes towards the hub, and then the hub could be your route reflector, for example. But ultimately, we're going to see the big difference here between phase 3 and phase 2 is that summarization is supported in phase 3, and that the next hop value is going to point to the hub, because we're not going to use the regular IP route anymore. We're going to use the next hop override route, or the NHRP route, which is going to allow us to do the dynamic spoke-to-spoke tunnels. Okay, any questions up to this point from just a high-level point of view? What is the difference between the phases? So again, we're going to take a look at this in much more detail from the configuration point of view. But again, the main difference is that in phase 1, the spokes run point-to-point GRE. In phase 2 and phase 3, they run multi-point GRE, but the difference is going to be what is the next hop value. If the next hop value is not preserved by the hub, so if the hub is setting it to itself, that means you cannot do spoke-to-spoke tunnels in phase 2. You would have to run phase 3, which is the ideal case anyways. You would want to run phase 3 because in phase 2 you're limited as to what the design you can do. So like when we run OSPF over phase 2, that means you're running a network type broadcast. If you run it over phase 3, you can run point-to-multipoint, which has better implications in the design. But again, from a realistic point of view, you would not want to do that anyways. There's a question, does phase 3 allow summarization and default routing on the spokes? Yes, the main idea is that from the spokes, you want to default to the hub. The hub is going to need to know all the specific routes anyways, though. So if the spokes have some sort of space that is aggregatable to begin with, yes, you could give them a summary from the spoke up to the hub, but the hub is going to have to be able to track those individually. So the spokes cannot just send a default to the hub, and then the hub's not going to know where to route the traffic. It's just that since the hub is the central point of control plane, and since it already has all of the next hops registered with it, you just default there, it gives you the actual resolution, and then that's how you're going to learn what the actual route is. Okay, there's a question, if you happen to use phase 3 and you do summarization on the spokes, then if the hub is supposed to summarize there too, would you need the discard route for OSPF on the hub? That's one of the problems that you can run into, because, and it depends on where you are in the hierarchy, because the issue is that if the, and let me draw this out visually, it's going to make a little bit more sense once we actually go to configure it, but the main issue that you run into is that, let's assume that this is the hub and that we have 3 spokes. Spoke 1, spoke 2, and spoke 3. Okay, now regardless of what the underlay is, somehow these devices have transport to each other, and somehow they have these multi-point GRE tunnels. Okay, so we're assuming like over the internet they're able to route to each other. Okay, now we want to run MGRE, and we want to run OSPF over this. So we're going to have a single subnet for the entire overlay tunnel. Let's say we have 10.0.0.0/24. This means that all of the spokes would need to be in the same OSPF area as the hub. Now, there are cases where you can have multiple areas on the interface, but this is not going to be one of the supported cases. Effectively, all the spokes need to be in the same OSPF area. So what this means is that if spoke 1 is advertising prefix A, and spoke 2 is advertising prefix B, and spoke 3 is advertising prefix C, we basically only have 2 options in order to configure this network. Either the DMVPN can be area 0, and the stub networks can be separate areas, or the entire network needs to be one area. Generally area 0, or if we don't have area 0 anywhere, we can just run one flat area. But let's assume everything is in one area, and then beyond the hub we have area 0. What this means is that when the hub does summarization, it can only do it in that direction. It cannot do summarization in this direction. Or in other words, the spokes would always have all specific routes about all other spokes, because the OSPF hierarchy enforces it. that if they're in the same flooding domain, they have to agree on the database. So even if we did an area range on the hub, it's not going to help. But in the case of EHRP or BGP, since the hierarchy is arbitrary, the spokes don't have to be in the same flooding domain. They don't have to be in the same query domain for EHRP, because we can just say summarize from the hub up and then do a default route summarize from the spokes up and then do a default from the hub back down. And then the spokes are just going to query the hub for all particular destinations. So it's really an issue of what is the OSPF area placement that you cannot summarize within an area, which causes the problem.